Brakes. Brakes convert kinetic energy into heat energy via friction pads and dissipate it to the atmosphere. They are usually fitted to main wheels only, but some transport aircraft, for example the Boeing 727, have them fitted to the nose wheel also. Types of brakes may be drum, single disc, or multiple disc. Drum brakes. An asbestos-lined shoe contacts a rotating cast iron drum when a brake application is made. When brakes are released, a spring moves the friction material away from the drum. This was fitted on the Lancaster. It suffers from fading, which means that during a brake application, the drum expands away from the linings and effectiveness is reduced. It's still used on some light aircraft. Single disc brakes. The disc is driven by the wheel and has two stationary brake pads on either side. Two hydraulically actuated pistons squeeze the disc when brakes are applied. Fading is much reduced compared to a drum brake. Multiple disc brakes are an extension of a single disc brake. Layers of discs placed between pressure plates are sandwiched between a piston assembly and a backing plate. Heavy-duty brakes are typically found on modern transport aircraft. Brakes operating systems. Foot brake pedals are hydraulically connected to wheel brake units by a directly coupled independent system, low pressure on small aircraft, or a main hydraulic system on large aircraft. Accumulators are included in the system to provide a limited number of application of brakes in the event of a system failure. In a low-pressure system, a brake master cylinder and piston are mechanically connected to brake pedals and are hydraulically connected to the brake piston. Here's an example of a low-pressure system. In a high-pressure system, there's a dual brake control valve connected to a main hydraulic system via a non-return valve and pressure-reducing valve. Inputs from pilot foot brake are also connected to the dual brake control valve. The output is connected to brake units via twin modulator, anti-skid unit and brake pistons. An auto-retract brake system automatically applies brakes as landing gear retracts. Maximum brake energy speed, VMBE, is the highest speed at which takeoff can be abandoned within the energy capabilities of the brakes. V1, decision speed, must not exceed VMBE. Brakes must be allowed sufficient time to cool between flights so that sufficient brake energy is available to stop aircraft in the event of a high-speed abort. Here's a diagram of a high-pressure system. Anti-skid systems. These prevent wheel skid and therefore improve brake efficiency. They only operate when an incipient wheel lock occurs. A tyre deceleration is detected and brake pressure is removed from the slower turning wheel, allowing spin up again. Brake pressure is then reapplied. The inputs are idle wheel speed, braked wheel speed, and the desired wheel train slipping rate. Systems may be mechanical or electrical. A modulator valve is a form of hydraulic restrictor which restricts flow of fluid to the brake unit after initial brake application and conserves main system pressure. It tends to smooth out brake operation. The modulator also shuts off the line and maintains pressure in the brake. If a leak occurs at a brake unit, the modulator acts as a fuse valve and isolates the leak. Auto brake. This allows a level of deceleration to be selected before touchdown. It provides a level of braking with anti-skid, providing idle power is selected. The pilot initiates disconnection by pressing brake foot pedals or advancing the throttle.